Okay, so just a little background. So I'm teaching this module called Computational Reasoning. The module code is GET1050, but now with the changes in the GE pillar, it will be called GEI1001 lah. And I was actually given quite a very challenging task in teaching this module. First of all, when I started teaching this module, I was given 800 students each semester. All right, and then all the lectures have to be in the form of video lectures, and then there's no lab session. So then I only have 5 face-to-face tutorial sessions with my students. Yeah, so that was a huge challenge, and especially when it comes to FASS students, a lot of them will tell you, oh, we joined FASS because we're bad at math. We joined FASS because we don't want to do any of these kind of technical things. So there's also a kind of like emotional and psychological barrier involved, and so that was actually quite tough to be able to solve all these challenges lah. So but here in today's session, I want to share 4 problems that I actually identified. And by solving these 4 problems, I was able to really get them on board. I was able to help them to learn effectively. In fact, so effectively, right? I'm very proud of my students because by solving these 4 problems, right, they become so confident, so conversant in computational thinking and also in basic coding, right? Many of them actually write in to tell me they actually got internships. You know, sometimes during the interviews they have to do programming tests and all that. They actually can do, and they get the internship. So I'm super proud of my students. Yeah. So what are the problems? So I'll start first with 2 problems. Okay. These 2 problems have relate to the way we teach computational thinking or coding. The first one is this: many things that seem evident are not evident to beginners, and I see this. I used to work with some SOC profs, so actually 2 SOC profs before to teach a module, right? And one thing that stood out was, and it's not just with these 2 SOC profs. I also realized that there are many public courses teaching CT and coding. I have friends who actually sign up for those courses, and the same thing happened. What was evident? Things like conditionals, things like loops, you know, if then else, do while, do until, and for loops, right? Many of the instructors actually thought that it was very self-evident. They can just briefly mention and then don't actually drill the students in it. So then I found that a lot of the people taking these courses, right, they just felt very lost because they're like, oh, I don't know what is this if then else. I don't know what is this do while, do until. Yeah. So this is one of the things. Yeah. Even things like pattern recognition and stuff like that. We think sometimes we think it's very evident. It is not as evident to them. Now, the other thing that I discovered, actually by chance, was that beginners lack mental resources to conceptualize abstract thinking. So it's very interesting, you know, like I can sit in front. Okay, how I discovered this was I met some students for consultation once at Starbucks, all right? And then I was trying to explain to them how this algorithm works. I mean, they tried to write an algorithm in pseudocode, but they couldn't see how it plays out. Then I said, why don't you do it on pen and paper? Couldn't really. They still didn't know how to do it, right? So then I took out, like, you know, Starbucks has a corner with like sugar packets, right? So I took the sugar packets and then I said, okay, according to this algorithm, right, we do this, then I move the sugar packet, okay, now you do. Then they start to move the sugar packets. Then after that, they start to realize it. Then when I started to see more and more students for consultation and with the sugar packets and all that, more and more people start to get it. And then it clicked to me that a lot of them are actually, they can do the abstract thinking, but what they lack is that they need the ability, they need something to visualize first, so that when they handle the problems, they know how to play it out in their minds. Yeah. So this was something that I realized lah. So yeah, just to recap. So this thing, right? We cannot take conditionals and loops for granted, and I actually cover this in great depth when I teach my module. So I have one whole lecture, one whole week dedicated to conditionals, one whole week dedicated to loops. You know, and yeah. So yeah, and then one of the things. Oh, I wanted to say one thing about the imagination. I found out this thing which is very interesting. Okay, let's say for example, if I ask you to imagine a beach, okay, how many of you can actually see the fine grains of sand in high definition detail? Cannot, right?
Not really, yeah.
Do you know we are actually a minority? Like there are people who say that they can imagine, right? They when I say imagine a beach, they can see the fine grain of sand, like HD detail. So that's the majority of people. So people like us who cannot visualize very well, we handle abstract things very well, right? But the majority of people, when they imagine, like one of my TA, she says, when I read a book, it's like watching Netflix. That is how high the quality of imagination people have, you know. And the majority of people are like that. Yeah, it's shocking, right? what have we been missing out in life? So because we cannot see very clearly in our imagination, we don't rely on that. So the way our brains work is very different, right? We can just use abstract examples, very mathematical examples. It works for us. It doesn't work for them because they are so used to seeing, you know, they can imagine in high definition, you know, and they're so used to actually picturing things and stuff like that. So the majority of people are like that, and when we give them this kind of abstract, like mathematical examples or whatever, right? They just don't know how to visualize it. So one of the biggest lessons I learned is that because the majority are like that, we do need to have illustrations or whatever, or even better, if we have tutorial or face-to-face lessons, right? Actually let them touch and hold things and move things around, then they actually grasp it better. Yeah. So but there's one other thing that I also realized, which is one of the problems with abstract examples, right, like mathematical examples, or, you know, like come up with an algorithm to do odd numbers or some odd numbers and all that. It's very hard to tap into that existing knowledge and intuitions. Yeah, it's very hard for them to tap onto it. So one of the feedback I get from a lot of students when we do things like that, right, is they say that oh, you know, this thing is so abstract, it's so far away. Oh, computational thinking is so alien, you know. But actually, I mean, for me, I thought it was actually very intuitive. So one of the things I realized is that we need to situate it in scenarios that that they can relate with. Yeah, then they can see the intuitiveness of it, you know. Yeah, so okay, let me just jump slides here. So so by giving them examples, later I'll show you some pictures lah. But basically, what I do in my module, right, is I give relatable examples of problems. It doesn't have to be so I give two kinds of relatable problems. One, problems that students can relate with, like let's say they need to take bubble tea orders. Yeah, so then, you know, let's come up with an algorithm to collect bubble tea orders. You know, and actually, in its most abstract, is we just like if x equals to 1, then a equals a plus 1 or something like that, right? So, but we, instead of using x and a, right, we just use things like bubble milk tea with pearl, milk tea without pearl. They understand better. They are able to map it better because it is less abstract. Yeah. Then that becomes familiar, and especially when we use familiar scenarios. Like I was talking to a friend, and then he said, why not, like greedy method, for example? Why not you talk about giving the change for money? So let's say you're a cashier, then the item is 392. Then the person give you $10 note. So how will you return the change? So intuitively, we're all doing greedy method, because we start first with the biggest note, and then we go down, right? So actually, when we give examples like that, that is very relatable, then they start to realize, hey, actually this thing is not so alien. It's actually very, very intuitive. Actually, we have it within us. So I always use these examples and I focus on that and say, you see, it's actually very intuitive. You have been using it in your daily life. Then they start to see it not so alien already. Yeah. Now, then one of the things is relate city concepts to real life problems. One other thing I do to really get them to buy on board, come on board with the course, right, is I actually talked to a friend who's a business analyst. He used to be at Lazada, but then I actually sat down with him and asked him for the kinds of problems that he do. Then I mimic some of them. Some I simplify a lot, some I adapt, right? And I actually tell the students explicitly, you know what, all these problems I'm giving you is because I sit down with alumni and talk to them and then simulated their problems. Wow, then I said, you know, I'm preparing you for internship in the working world. Wow, they really come on board with it. Yeah. So now there's an added benefit to this, which is because when we give them in this kind of situations, right, they also see how the tools can be applied. Because one of the problems, even I experienced this when I was learning programming, which was like we were taught, right, we were taught very things in isolation, like array, loop, conditional, right? And we're not given a context, but to really put all this together. I mean, yeah, the context is an abstract problem, lah. Like, can you make a loop to multiply the number of asterisks on the screen or whatever, right? But this kind of problems don't help students to link how to solve actual problems in the real world. So when I give them problem sets based on like what my friend does in Lazada, right? Then they start to it's nice because many of them actually, when they go on internships, right, they start to say, hey, this problem is very familiar, this problem is very similar, I know how to do this. They say, hey, yeah, this module taught me this in week one. I know how to do. Yeah, so there's an instant plug and play, and then after that, now the module has a very good reputation. The students actually tell them, tell their juniors and their friends, you have to do this module. Even if you did CS1010, you still have to do this module because you can do well in internships. Yeah, so that's the added benefit, lah. So yeah, like I said, I avoided all the abstract mathematical examples, right? So what do I do? Can you see? So I do things like in the quizzes, I have things like aerobics exercise. I mean, okay, this is me being some other funny character, but yeah. So I will do like aerobics exercise. Then I this for the question about loops, right? So I say this guy is trying to do a exercise program. So but we're calling algorithmic aerobics. So which of this algorithm is going to execute the right number of like jumping jacks or whatever? Then that's how the exercise is done left and right, yeah. Or things like finding cereal in the supermarket. So we say, you have to go down every aisle from aisle 1 to the last aisle, right? And then you will find the thing. It's very relatable. And just like I say, we collect bubble tea orders. All these are actually, it's all adapted from the typical kinds of examples that we normally give for CT coding classes, But instead of just using like A or X or whatever, we just replace it with a story. So the trick I do is I always have a story, a silly story or whatever, or a realistic story, and then and then it's just about like finding fruit loops or exercise and stuff like that. Then they connect better. Now I talk about they must touch and feel, right? So my team actually created learning games as well. So we have a card game. This is called the game that they invented is called Algorithm. So over here are the gorilla enemies, okay, and the cards that they're holding, right? There are the yellow cards are conditionals and loops. The blue cards are action cards. So like maybe -2 HP. So if I put the -2 into a do while loop, then I can multiply the -2 effect. So let's say do while do until enemy life is has reached half of its original life. So then let's say then it's played in a group setting because then the students will have to talk to each other. So those who don't know how to interpret, right, and those who know how to interpret the pseudocode, they can correct one another, they can discuss and they can learn. Now, and then we play a few rounds into, okay, this was before COVID, right? So we play a few rounds, and then I think by half an hour later, a lot of them can already do the mental sums for loops already. Yeah. Before that, many of them struggle. I have to get them to sit down with pen and paper and stuff like that. Then I say they have to touch and feel, right? So for when it comes to greedy method, greedy algorithms, we have this game called Greedy and Bias. So it's a bit like Risk, but then they just move the wooden blocks, and then again it's done in a group setting. They play against themselves within a group, and they formulate greedy methods, greedy rules, and then they ensure then basically they're policing each other to make sure they follow their rule, Yeah. So this is something that really helps reinforce their learning. One other thing that I do is before I go straight into coding, I actually drill them in pseudocode for 3 weeks. Yeah, because this was actually my learning experience, and I found it very useful. Because last time when I tried to learn coding myself, I really struggled a lot. I opened the books, I watched videos on the internet, I don't understand, right? So when I finally had a coding teacher, we had to do pseudocode, we had to do pen and paper, and so that was very effective for me. And so I actually introduced this to my students, and we do 3 weeks of drilling. And once we do 3 weeks of drilling, we go straight into the VBA coding, most of them can do it. Most of them already master the concepts. They understand conditionals, they understand loops, they know how to put it together, more or less, they know how to put it together in a way. So when it comes to the actual coding, they struggle less. Because one thing I realized with coding, right, a beginner who comes in with coding struggles with two things: the language, the syntax, and the computational thinking. So I rather separate the two. Then they concentrate first on the computational thinking with the pseudocode and with all the games. Then once they have a more or less an understanding, then we go into the coding. Yeah. Okay. Then two more problems that I want to talk about, which is actually very pertinent to students outside of computing. It's not just art students actually. And I know this because I talk to my students and they tell me, that their friends taking modules in the Faculty of Science and all that, they also struggle with it. So it's something that I've recognized is something that we do need to address also lah. So what are the two problems? The first one is fear of failure. Fear of the unfamiliar. Of course, it's stronger in FASS lah, because this is a coding, CT, right? Coding and stuff like that. It's very alien from what they're used to. But even for some of the science people, okay, it is also very alien to them. Okay, I talk to people from pharmacy and life sciences. It's very they don't see CT as anything complementary to their major. They just see it as something super alien, right? So that fear, and especially when it's graded, it adds a lot of anxieties. Yeah. Then there's another thing called the lack of intellectual self-trust, which is something quite interesting. Intellectual self-trust is our ability to trust that our minds can come up with the correct answer. Yeah. So when it comes to new and unfamiliar territory, right? Already they don't trust themselves enough because okay, I'm not competent, maybe I'm not right? Then but this problem needs to be addressed. We need to actually reinforce this self-trusting, right? We need to help them to overcome all these psychological issues, because if not, it actually plays out it can really backfire. I give you the most extreme case. Okay, this is a reflection from a student who has been repeating the module because we got a number of students who are so scared that they actually just don't do the module at all. Every semester we have a handful of them. So this student repeated 3 times and finally she has to graduate. So she did the module. She finally took it seriously. Yeah, and you see she talked about how the fear, how she kept running away, and then finally since she has no choice to graduate, it's a graduation requirement. She overcame that fear, and then she started to understand that that it's really a case of we fear what we don't understand. Yeah, so this is very true for a lot of students. Now, so one thing that I find very, very effective, right, is that, especially when it comes to coding proper, right, many courses don't actually teach students how to spot and correct errors, because that is actually the biggest, the most common mistake. They make a typo error, they don't see it, and then many of them don't know how to read the error. So what I found I made myself, I told students, you don't know, you can message me lah. Then the first 1.5 years, oh my gosh, when you come to the coding section, a lot of them bombard me with messages like throughout the week, every day, because they don't know how to fix the error, and it actually impacts their intellectual self-trust very heavily, because they say, hey, I follow the lecture, right? I type, I follow exactly. Why the thing don't run? Am I that stupid? They actually think like that, and their confidence really drops significantly. Some of them code until they cry because they just don't understand what the error is. So what I did is, firstly, I normalize the culture that errors are common. I make a video where I say, it's actually very, very common. Like tell them stories like last time I take coding modules in computing. Then got people always at 3 a.m. in Com1 building shouting, where's the error, where's the missing semicolon and stuff like that. So I tell them that it's very common to have errors. So just because you have a typo, just because your code don't run, that is normal. Like 90% of the time, people are spending time actually fixing bugs than they're actually coding. Yeah. Then I also have quizzes to reinforce the self-trust. So one thing I do differently is my quizzes, right? Students have 5 attempts. 5 attempts to do. So less anxiety. Yeah. They don't, if you give them only 1 attempt, they will start asking you or the TAs to affirm that the choice that they choose is the right answer. So you give them 5 attempts, they feel more willing to try. But I also have a lot of quiz questions that are dedicated to spotting errors and fixing it. So I introduced this in the fourth semester, right? wow, I tell you, the number of queries I get online actually dropped quite a lot, because after a while they become better. Of course, you still have the blur ones, but then the blur ones that I say, you remember quiz 4, question 7, then they, okay, yeah, something like that. So that helps. I also have this thing called an interactive story game. Let me just show you interactive story game. So basically, it's what choose your own adventure kind of thing. So I take a lot of photos, and these are all me lah. Use an app, but I have a story, that plays out, and basically I have 3 stories that guides them through both the technical things, the technical process, and also the soft skills, the critical thinking skills. But I also do negative demonstrations. I record snippets lah, negative demonstrations where the errors happen and how to fix these errors. Yeah. Then of course, lastly is support structures. Now, what do I mean by support structures? I have things like lecture Q&A, and this is a Google Docs because every time they ask me a question that's not in here, right? Then I add it in. So when they have like five attempts, the first time they do, okay, then they find out they didn't get full marks. They start to refer to this, yeah. Or if they ask me a question, I say, okay, look at the Q&A question 7, something like that, So then they also recover a lot of the ownership and responsibility of learning, yeah. And it builds their self-confidence also, because if my first quiz attempt, I got like 5 upon 10, right? Then I do a bit more work, I get 7 upon 10. They feel more confident of themselves. Then when they do the third attempt, they get 9 upon 10 or 10 upon 10. What the feeling of shock, the shock feeling they get is very, very high. And then they actually feel more confident of themselves. Once they do this, they feel confident, they can proceed to do other activities in my module. So what do I make them do? I do make them do classification models to sort movies, classify into horror, sci-fi, or fantasy. Yeah. I give them things like greedy method to solve delivery problem. Yeah. And then and this is like the final personal challenge lah. They have to write code to solve this maze. So it starts from yellow, and he has to automatically find his way to the red. Yeah. So in the beginning, when I implemented this without all the things I talked about, right? Wow, I tell you, I die when I introduced this assignment, because they really so many students, 800, come and find me for help. But after I implement all this, right, it dropped significantly. And now I'm very proud to say this semester, right, I still need to reflect on what I did, right? But I did something very right this semester. Most of the students, right, I can just, when they start, I just need to tell them in English. They know how to write the code. They know how to fix it. I don't need to tell them I don't need to copy and paste any VBA for them. Yeah. And one of the things that to really get them to enjoy learning, right, to give them the ownership, right, is I have one activity for them, is that they have to go and come up with their own come up with their own game. Now the trick is this, you get them to come up with their own story, because once they come up with their own story, right, then they're psychologically invested in the game already. Then they have a sense of pride already, and a lot of them they tell me, wow, they feel very shocked, letting their parents play the game, giving to their friends to play the game, So as because they want to have this sense of accomplishment, wow, they are so driven, and many of them actually go above and beyond the Call of Duty to go and add more features than what's required in the question. Yeah, so that as they slowly play and mess around, what they call in the education pedagogy, or undirected learning, because I give them time to just mess around, right? They learn new things, then they try, hey, what if I can get the character to do this other thing? How do I do it? Then they sit down, they talk to their friends. So they learn very effectively from this activity. I say, make your own game. Yeah. So I just set a few requirements. There must be an ending, there must be a computer character that they have to talk to that will change the game and stuff like that. Yeah. So at the end, this is an example. This student, right, she applied for internship that's normally for year 4. She's year 2 only. And on the spot, over the Zoom interview, they actually gave her a programming test. And she was able to do it, even though she just learned coding from my module for the first time. Yeah, so yeah, I'm very proud to say that these are the things that work lah. But basically, I mean, I'm not saying you have to do all these things. Okay, what I'm saying is that we need to address these 4 issues. Yeah, the 4 problems. When we can address these 4 problems, then they will learn a lot better. And all the things that I did were just examples of how I did it lah. But I'm sure you can have your own ways of doing it lah. Yeah.